Hi, I'm Bruce Kyle. I'm an architect evangelist at Microsoft. I work with software companies in the Pacific Northwest. I'd like to introduce Stuart Solarier. Stuart is a software architect with CheckFree and a Microsoft Most Valuable Professional.
Hello, I'm Stuart Solarier, and I blog at visualstuart.net. I'm a Microsoft MVP on connected systems, and until now, most of us have been programming in C# 1.0. From that .NET 1.1 era, and even if we've got a newer version of the language, we're still using it as if it were C# 1.0. We're going to take a look at what's new since 2003. What changes the way we program? We're going to focus on the language, not practices, not applicability, not even usefulness. So opportunity for abuse abounds. We're going to do just enough to be dangerous.
Hey, Stuart. What's today's Whirlwind?
Today we're going to talk some more about C# 2.0, in particular, iterators, one of my favorite topics. This is a play in 3.5 acts. First act, let's talk about enumerators, the way they were in C# 1.0. So there's an IEnumerable interface that has a getIterator method on it. And if I implement IEnumerable, fill out getEnumerator, it returns an IEnumerator. I get two methods and a property as a result of that. Those two methods are to move to the next element, to reset my iterator, and a read-only property, current, to get the current element. And since this is .NET 1.0, we don't have generics, so current returns something of type system.object. So here's ArrayList. It inherits from IEnumerable, so if I new one up and add some items to it, then I can use the for each syntax to enumerate over the items in list and do something with it. So I've highlighted the two keywords for each and in, as well as use of the variable to which individual elements of the collection are assigned. And if you think about it, behind the scenes, the C# compiler must be generating some code that looks something like, well, the for each call gets turned into a call to getEnumerator. Each time we evaluate in, we're moving to the next item. And finally, when we use the item, that's getting the current property. And since current returns a system.object, that has to be cast to a string. So the cast is kind of the part that I want to draw your attention to. Because in Act 2, where we have generic enumerators as part of C# 2.0, well, now I have IEnumerable of t as a new interface. And it's interesting to note that it actually inherits from IEnumerable, the non-generic version. So now getEnumerator returns IEnumerator of t. So we're getting strongly typed t all the way through this. And the important thing to notice about IEnumerator of t is that current now returns something of type t. It returns a strongly typed return value. So now if I consider list of t, which inherits from IEnumerable of t, I've got the same sample usage with being able to use the for each syntax to iterate, the for each syntax to enumerate over the collection. And now the pseudocode that's generated underneath in the C# compiler, there is no cast for the current property because it is returning something of the correct type. In this case, we had list of string. So in the bottom line, e.current returns something of type string. Well, here's your bonus half act, which is, what about implementing those enumerators? How much fun is that? Well, let's consider an animal class and an animal list class that is a collection of animals. And because I want to be able to have people use the for each syntax, I'm going to have it derived from IEnumerable of animal. And I have a way of getting an enumerator. I'm going to use the same enumerator whether it's the generic or the non-generic form. And this is a pattern here down at the bottom, is I'm going to make that actual enumerator class, the thing that does my enumeration for me, I'm going to make that be a private class, a nested class within animal list. And that's done for convenience so that now the animal list enumerator has access to all the private members in the animal list class. So what about that nested enumerator class? How much fun is that to write? Well, it's about 40 lines of code, bare bones minimum, and a bunch of that is just boring boilerplate code too. However, there's also an interesting subtle condition that we have to check for and return an error, and that is, what if somebody should call current before move next is called the first time? That's considered an error. I have to remember that if I'm writing an enumerator, and so that's the red comment shown in the right-hand column there. It's subtle. Now I have to deal with remembering to do that on every enumerator that I write. It's just a lot of hand-holding. If you think about it, this whole thing is a lot of work. Just for a simple forward enumerator on a simple list, there's going to be more work involved for alternative enumerators over different collections, and even more work if I'm trying to do an enumerator of a complex data structure. So this is going to be a big headache if I want to use enumerators a lot. Enter iterators. We're going to let the C# 2.0 compiler write the enumerator for us. So let's consider that same animal list collection class. It's a collection of animals. So it still inherits from IEnumerable of animal. And I'm going to let the compiler do the writing for me. So in my getEnumerator method, in the body of that method, I'm going to write an iterator. The iterator is indicated by the new keyword yield. The new keyword yield means the compiler is going to write a state machine and maintain that state, and every time it executes, it's going to pick up execution where the previous yield left off. So let's just flip back here to our iterator. This one says is a for loop iterating over the index of all of the elements in the list. And it says yield, return this value, and the value that it's returning is the item of list indexed by the current indexer. So this is going to get called as many times as there are elements in the list, and every time it gets called, it's going to yield up the next item in the list. So I can think about writing alternate iterators, because it's not much work. So here's a reverse property that is of type IEnumerable of animal. It has a get, and this counts from the top index down to 0, yielding up the successive values of the collection list. An example of how I might use that is down in the bottom right-hand corner for each animal item in list.reverse. So it gives me a nice syntax, and I'd much rather write those 2 lines inside of the getter for reverse than another 43 lines of generating my own state machine. Now I can write all sorts of flexible iterators. For example, nobody said there couldn't be multiple yields in there. So the first time that we move next in test aquatics, we get the manatee animal. The second time that we move next and call current, we get the animal narwhal, and so forth. Now I get to implement depth first iterators, breadth first iterators, get down, get funky.
Hey, thanks, Stuart. For more information for software developers, see the US ISV Developer Evangelist blog on MSDN.
Hey, it's been fun. Again, I'm Stuart Solarier, and I blog at visualstuart.net. See you next time.